Hello everyone. So today we will learn about how we can create two-dimensional NumPy arrays. So what are the different ways of creating two-dimensional NumPy arrays? So the first method is by using the array function. So the array function that you used for creating one-dimensional ND arrays can also create two-dimensional ND arrays or any n-dimensional ND arrays. The only thing you need to take care of is that the list or tuple that you are passing to it should be a two-dimensional list or tuple. So the same array function can also be used for creating two-dimensional ND arrays, but the only thing is whatever list or whatever tuple you are passing through should be a two-dimensional. So you see, the syntax of the array function is the same as the one-dimensional array. So let us take one example. Suppose we have taken one list L1 equal to, we have passed two lists. First one is 1, 3, 5 and the next one is 2, 4, 6. So you have created the array ND2. So this is the name of the array equal to np.array. Using the array function, you have passed the list L1. So what will happen? Your array will be created as array 1, 3, 5, 2, 4, 6. So it will have 2 rows and 3 columns. So this is a two-dimensional array. So you can see here the screenshot is given. List 1 equal to, here you have passed the first list and here the second list. Then nd2 equal to np.array list 1. Now when you have typed nd2, the array is coming like this. Now if you want to see the shape of the array, what you will do? nd2.shape. So 2 rows and 3 columns. So the shape of the above created nd array nd2 is 2 into 3 or 2 cross 3. That is 2 rows and 3 columns. Now you see, in the same way you can create a two-dimensional array from a nested tuple. So here you see you have taken a tuple T1 equal to, first you have taken 2, 4, then 3, 5, then 6, 4, then 5, 6. So there are multiple tuples. So this is a nested tuple. Now you have taken the name of the array as ND3. So ND3 equal to np.array. In the dot array function you have passed the tuple. So you see the screenshot here, this is the tuple. Here you have written nd3 equal to np.array t1. Now when you will press or write nd3, then see your array will come in this pattern: 2 4, this 2 4, 3 5, 6 4, 5 6. So the shape is 4, 2 because it has 4 rows and 2 columns. So nd3.shape is 4, 2. So this is how you can create two-dimensional ND array by using the dot array function. Now the next function is the arrange function. So you see, about the arrange function you have already learned in one-dimensional ND array. Now you can use the same function, but in case of two-dimensional array you have to use the reshape function along with the arrange function to create a two-dimensional ND array. So what you need to do first is create an ND array using the arrange function. Then reshape the ND array created in the previous step using the reshape function. So you see the syntax is ND array means name of the array dot reshape. Then you have to give the shape of the tuple, whatever shape you want. Okay, so you see the examples here. AR equal to NP dot arrange 10. So it will have 10 values starting from 0 to 9. So when you have pressed AR, the array is coming in this form. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So all total there are 10 elements. Now you have to reshape it. So for this what you have to do, you have to create one more new array. AR1 equal to this AR dot reshape. Suppose 5, 2. So why we have taken 5, 2? Because 5 into 2 will give you 10 elements and we have 10 elements here. So when you will press AR1, you will get this array. There are 5 rows starting from, and the elements are starting from 0 to 9, and there are 2 columns. Similarly, you can give 2, 5 also in the reshape function. Then what will happen? It will have 2 rows and 5 columns. So this is how you can use the dot reshape function along with the dot arrange function for creating two-dimensional arrays. Now you see, whatever we have seen here, it is explained here. The first statement above, that is AR equal to NP dot A range within bracket 10, creates a one-dimensional ND array with 10 elements. Now the second statement, that is AR1 equal to AR dot reshape 5, 2, creates a new reshaped two-dimensional ND array with 5 rows and 2 columns. And the third statement, AR2 equal to AR dot reshape 2, 5, creates a new reshaped two-dimensional ND array with 2 rows and 5 columns. Done. So all the three ND arrays created above have the same number of elements in total. So they all have 10 elements in total. Now you see, the shape of originally created ND array using the arrange function must be compatible with the new shape that you specify with the reshape function. Means whatever the number of element was present in the original ND array, you have to keep that in mind and use the reshape function. So you can see the example. If you originally created an ND array containing 9 elements, with arrange function you can easily reshape it into a two-dimensional ND array of 3 cross 3 size, because 3 into 3 will give you 9 elements. But you cannot reshape it into 4 cross 2 or 5 cross 2 shapes, because 4 cross 2 will have only 8, 5 cross 2 will have 10 elements, as these are not compatible with the original shape. So you have to keep these points in mind. Next you see, you can also combine arrange function and reshape function in a single statement. Okay, so in the earlier example, first we have used the dot arrange function, then we have used the reshape function, but you can do it in one single statement also. So you see, for this you have taken the name of an array as ARY equal to np dot arrange 8.0 dot reshape 2, 4. So it will give you elements from 0 point up to 7 point, because the range is up to 8.0. You will have all total 8 elements from 0 point to 7 point. And the reshape you have given 2, 4. So it will have 2 rows and 4 columns. Done. So this is how you can create two-dimensional ND arrays. Now let us see how NumPy arrays are internally stored. Okay, so for this you have to see, internally a NumPy array stores. First you will have a header. This will contain information like data type of the elements. If the array is read only, means you cannot edit the array. The byte order, that is if it is stored in a row measure form or column measure form. Done. Then you have the dimensions of the array, means if it is 1-dimensional, 2-dimensional, 3-dimensional, whatever it is. Then you have data part, storing the reference link of the actual data. So whatever data you have stored there, there will be a link, reference link. Then you have strides. Since internally all multidimensional arrays are stored linearly in contiguous locations, that is example you know only, that is row measure or column measure form. So the strides store the number of bytes to be skipped to move along one axis. So if you see the diagram, you will understand it better. Okay, so see, first in this picture you see, for the NumPy array, first you will have the header, then you will have data, it will have a link where you will have all the data you have inserted, then its dimensions, then its strides. Now you see here, in the header part you have the data type. So the data type is float 32. The float 32 data type describes the array data elements. So whatever elements you are going to insert in the array, all the elements will have the data type as float 32. Then you have the dimension count. If it is given as 2, so it is a two-dimensional array. Now you see dimensions 3, 3 means there will be 3 rows and 3 columns. Okay, so you see, next you have strides. Strides is 12, then 4. So if you see this picture, you see here, so this is a row measure arrangement. Okay, so here you see, this is one row, this is the first row, this is the second row, and this is the third row, and in each row you will have the individual columns. So it is 3 and 3 rows and 3 columns. Now you see each block is of 4 bytes, okay, and as a whole one row will be of 12 bytes. So if you have to move from one element to another element, it will occupy 4, it will take, you have to go for 4 bytes, and if you want to go from one row to another row, 4 plus 4 plus 4, all total you have to go move for 12 bytes. So you see what is written. The strides tell that to move to next element in a row you have to move 4 bytes, and to move to next element in a column you have to move for 12 bytes. Done. Then you see this is the Python view of this is the Python arrangement of the elements. Okay, so in Python it will be arranged in this form. When you check the size of an array, it gives you more number of bytes than just the data. So you see when you will write AR3, the array will come out like this with data type int 16. Now from system import get size of. So you are using the get size of AR3. So in system it is taking 56 bytes. So you see although 9 elements with size 2 bytes each, means in 16 store only 18 bytes, but the array stores much more. Okay, so though it is of 18 bytes, but in system it becomes large and it occupies more bytes, that is 56 bytes. Done. Now there are some more alternative ways of creating arrays. So here you can create both one dimensional and two dimensional arrays depending on the arguments passed. Means whatever, if it is a one dimensional argument passed, it will be in one dimensional array, and if it is a two dimensional argument passed, then it will be a two dimensional. So let us see this. First is creating empty arrays using the empty function. Okay, sometimes you need to create empty arrays or an uninitialized array of specified shape and data type in which you can store actual data as and when required. For this, you can use the empty function. Okay, so see what is the syntax. NumPy.empty. Here you will have shape, then the data type, and the order equal to C or F. So let us see what each of these means. Shape specifies the dimensions and is given as list, means rows comma column. Then order as C arranges array elements. This will be row wise, not column wise, row wise in memory. That is first row's element, then second row's element, and so on. So C means it is C-like. Next, order as F arranges array elements column wise in memory. That is first column's memory, first column's element, then the second column's element, and so on. So here F means it is Fortran like. Okay. Now both data type and order are optional. So both these options are optional. By default, the data type is taken as float. So by default, the data type is float, which we have already learned earlier. Okay, that is when you do not specify any data type, then by default it is float. Similarly, the order, that is the order, mean it in which order it will be arranged, it is by default C. So by default the order is C. Okay. Now next, after creating an empty array, if you display the contents of the array, it will display any random contents, and these random contents are nothing, they are uninitialized garbage values. Okay, so you see the screenshot here. Suppose you have created arr1 equal to np.empty. Using the .empty function, you have given the shape 3, 2 means there will be 3 rows and 2 columns, but you have not specified the data type. Second array you have taken arr2 equal to np.empty, and here you have given the shape 3, 4 means 3 rows and 4 columns, and here you have specified the data type as np.int8. Now you see, when you will write arr1.d type and arr2.d type, since here you have not specified any data type, by default it will give you float 64, and here since you have already specified it is int 8, it will give you int 8. Now if you want to see how the array arr1 looks like, so you are writing arr1, so these will give you some garbage values. These are some random values generated by the computer system itself. So 3 rows and 2 columns, because the shape was 3, 2. Next is creating arrays filled with zeros using the zero function. So you see, the function zeros takes some attributes as empty and creates an array with specified size and type, but it will be filled with all zeros. So the syntax is same: numpy.zeros, shape, data type, and order equal to C or F. So in place of numpy, you can also use np, as we have given alternate name for numpy as np in the import statement. So this already I have told you in the first class. Then shape and order attributes work in identical way as in empty function. So shape and order is optional. You may give or you may not give. So let us see the screenshot. Suppose you have taken arr3 equal to np.zeros. You are using the dot zeros function, and here you have given the shape as 2, 3. So there will be 2 rows and 3 columns. Data type you have given as np.int64 and order equal to f. So you see, when you are writing arr3, you see you are getting 2 rows and 3 columns, because this was the shape. Data type is int64, and since you are using the dot zeros function, all the elements are filled with zeros. So this is the use of dot zeros function. Next you see creating arrays filled with ones using the ones function. So the function ones takes some same attributes as empty and creates an array with specified size and type, but it is filled with all ones. So the syntax is same again, but only you have to use the dot ones function, and shape and order attribute also works in the same way, means it is optional. So you see the screenshot. Suppose you have taken an array arr4 equal to np.ones. Shape you have given as 2, 3. There will be 2 rows and 3 columns. Data type you have given as float 32. So when you are writing arr4, you see it is coming in the form 2 rows and 3 columns, all filled with ones. Since data type was float 32, so it is coming as 1.1 and data type is float 32. Done. Now there are 3 more functions: empty like function, zero like function, and ones like function, that you can use to create an array similar to another existing array, that is having similar data type and order as the array whose name is given as attribute, but values to be empty or zeros or ones. So you see, you can do it in this way: empty underscore like, then the name of the existing array, zeros underscore like, name of the existing array, ones underscore like, and the name of the existing array. So when you will write arr3, you will get the array as 0 0 0 0 0 0, and this is the original array, suppose, and its data type is int64. Now suppose you are creating a new array arr4 equal to np.oneslike. You are using the .oneslike function and passing this array arr3. So when you will write arr4, you will get this array. So this array has the same dimension as this one. It has 2 rows 3 columns. It also has 2 rows 3 columns. Its data type is int64. Here also the data type is int64, because you have used the dot ones function and only the zeros are replaced with 1. Done. Next you see, there are some other useful array creation methods. So these are briefly explained here. First one is np.I function, where you have passed 5. So this will create a 5 cross 5 array with values 0 at non-diagonal positions and 1 on the diagonal positions. So all of you know what is a diagonal. Suppose there is a cross, these lines are known as diagonal. You have already learned diagonal in geometry, mathematics geometry. Okay, so all the diagonals will have 1 and the remaining portions will have 0. Next you have np dot full. Then within bracket, one more bracket is there. Here you have 2 comma 3 bracket close comma 6. So what this function will do, it will create a 2 cross 3 array and all the values will be 6. Next you see np dot random dot rand 3 comma 4. So this will create a 3 cross 4 array of random floats. All the values will be floats and the range will be from 0 to 1. Next you see np.random.rand 4 comma 5 star 100. So what this will do, this will create a 4 cross 5 array of random floats. Here also you have random floats, but the range will be from 0 to 100 because here it is mentioned, the limit is mentioned as 100. Next you see np.random.rand int 5 comma size equal to 2 comma 3. So this will create a 2 cross 3 array with random integers in the range 0 to 5. So 0 to 5, why? All total, because there will be 5, the total is 5. 0, 1, 2, 3, 4, all total it is 5. This 5 is given. Okay, so the range will be from 0 to 4. So that's all for today's class. Thank you.